Hello, my dear students. Welcome to my YouTube channel, Shiv Academy of Mathematics. Myself, Dr. Manoj Kumar Antil. So, dear students, in this video lecture, I am going to discuss again one of the important topic of complex analysis, the harmonic function. So, when we talk about the harmonic function, the definition is very simple. A function u x y is said to be harmonic function if it satisfies the Laplace equation. That is, del 2u is equal to 0. This what you say, this is the del operator or this is the nabla, or what you can say that curl 2u upon curl x square plus curl 2u upon curl y square is equal to 0. We are taking this u as the function of x and y, that's why we are writing here curl 2u by curl x square plus curl 2u by curl y square equal to 0. But if you are getting u as a function of x, y, z, then we will write that curl 2u by curl x square plus curl 2u by curl y square plus curl 2u by curl z square equal to 0. So dear students, when we have to show that any function is harmonic, what we have to show that function must satisfy this Laplace equation. And what is the Laplace equation? This curl 2u by curl x square plus curl 2u by curl y square is equal to 0. So dear students, now we are going to show that the function ux equal to e to the power minus 2y sine of x square minus y square is harmonic. So just I have discussed in the definition how we can show that a function is harmonic. We have to show that this u satisfies the Laplace equation. So to show that this u is harmonic, what we show here? We show that curl 2u by curl x square plus curl 2u by curl y square is equal to 0. So we compute these two second order partial derivatives from this one. So first of all we compute curl u by curl x, then curl 2u by curl x square, then we compute curl u by curl y, and then curl 2u by curl y square. So from 1, curl u upon curl x is what? That means to say what we are doing, we are differentiating 1 partially with respect to x. So it is e to the power minus 2y into x, it is y into x. So when we have to differentiate this partially with respect to x, so we apply the product rule. So we differentiate this. So it is minus 2 y e to the power minus 2 yx sine of x square minus y square. So we differentiated this e to the power minus 2yx with respect to x, this one as it is, plus now e to the power minus 2yx as it is, and the derivative of this sine x square minus y square with respect to x is what? Cos of x square minus y square into 2x. Cos of x square minus y square into 2x. So this is the derivative of u with respect to x. So now again we differentiate this curl u by curl x with respect to x. Therefore curl 2u upon curl x square is what? So again we get this minus 2y outside, it is 4y square e to the power minus 2yx, and this is sine of x square minus y square as it is. Again because there are two terms of x, first term is this, second term is this. So what we do again, we differentiate the sine x square minus y square, so it is minus 2y e to the power minus 2yx, and it is again cos of x square minus y square into 2x. And look at the second term. Here we are having three terms of x, 1, 2 and 3. So again we apply the product rule, keeping two terms outside and differentiating the third term. Sorry. So dear students, we take this 2 here. Derivative of this x is 1. Sorry. And these two terms as it is, e to the power minus 2yx cos of x square minus y square. Then we differentiate this with respect to x and these two terms as it is. So it is 2x cos of x square minus y square, and the derivative of this term with respect to x. So it is again minus 2y into e to the power minus 2yx. And the last term, what we write, these two terms as it is, 2x into e to the power minus 2yx, and the derivative of this cos with respect to x, that is to say derivative cos is minus sine of x square minus y square, and into this is 2x, derivative of this x square minus y square. So we get these 5 terms. So you can combine these terms and you will get this curl 2uy curl x square. Curl 2uy curl x square. Okay. So similarly, what we do, we compute from this one curl uy curl y and then curl 2uy curl y square. We take it as 2. Again from first, curl u upon curl y is equal to, again we are having two terms of y, one term is here, second term is here, so again we apply the product rule. So we compute the derivative of this, it is now minus 2x into e to the power minus 2yx, and the second term as it is sine of x square minus y square. Now this term as it is e to the power minus 2yx, and this derivative of sine, that is cos x square minus y square, and the derivative of x square minus y square with respect to y, it is minus 2y. So basically it is minus 2x e to the power minus 2yx sine of x square minus y square minus 2y e to the power minus 2yx cos of x square minus y square. So this is curl u upon curl y. So we find out curl 2 by curl y square. That means to say we are again differentiating this whole term partially with respect to y. So again look at this. In the first term there are two terms of y. In the second term 1, 2 and 3. Again we apply the product rule for the both terms. So this is minus 2x, and from here you again get minus 2x e to the power minus 2yx, and this one as it is sine of x square minus y square. After that you write minus 2x e to the power minus 2yx, and the derivative of this sine, again it is cos of x square minus y square into minus 2y. So these two terms are from the differentiation of this first term partially with respect to y. Now come to this term. Again you can look at here, derivative of this y is 1. We keep all these terms as it is, and that means it is minus 2 e to the power minus 2yx, and it is cos of x square minus y square. Now we differentiate this term, keeping these two terms same, that is minus 2y e to cos of x square minus y square, and the derivative of this e to the power minus 2y as it is, and it is minus 2x. And finally what you do, you keep these two terms same and we differentiate this term with respect to y. So it is minus 2y e to the power minus 2yx, and the derivative of this cos is again minus sine of x square minus y square, and it is again minus 2y. So we take it as 3. So because we have to show that the sum of these two derivatives must be 0, if you have to show that this u is harmonic, so we add 2 and 3. Adding 2 and 3, we get, so what we get, left side is curl 2 by curl x square plus curl 2u upon curl y square. So dear students, when we simplify the right side, we will get 0. Why? Look at this part. It is 4y square e to the power minus 2yx sine of x square minus y square. So if you look at this last term, it is 2y, 4y square, negative, negative, negative. 3 times negative means to say negative. So it is 4y square e to the power minus 2yx sine of x square minus y square. So it is plus, that is minus. So these two terms cancel out. Similarly, if you look at the second term, it is minus 4xy e to the power minus 2xy, and it is cos of x square minus y square. So look at this term, minus minus plus 4xy e to the power minus 2xy cos of x square minus y square. So when you add these two terms, definitely all these terms from this and this get cancelled out, and you get the value here 0. That means to say, we can say that this function u is harmonic. So dear students, keep remember that whenever we have to show that any function is harmonic, we have to show that that function satisfies the Laplace equation, and this is nothing, this is the Laplace equation. So problem is very simple, just you have to very careful to find the derivative, because we are getting derivative 2 times. So you understand the problem. So keep enjoying watching our videos, and don't forget to like and subscribe our YouTube channel, Shiv Academy of Mathematics. Thank you.